Hello, and welcome to Space for Sleep. I'm so glad you're here. Whether you're lying in bed, curled up on the couch, or just trying to let your mind drift after a long day of wondering about life and the vast unknown, you've found a quiet corner of the cosmos, a place where quantum mechanics whispers softly and the mysteries of the universe unfold one breath at a time. If you enjoy these late-night journeys through time, space, and possibility, don't forget to gently tap that like button and subscribe so you never miss the next trip into the unknown. Now, close your eyes. Imagine the stars overhead, steady, eternal, almost reassuring. But what if one night, long after we're gone, those stars began to fade, not from distance or dust, but because the universe itself had started to fold inward, collapsing upon its own vastness? What would it mean? If the universe began to end, not with a bang but with a great, slow fall? The story of the universe has always been told as an expansion, a vast breath that began almost 14 billion years ago, with the Big Bang. Space itself stretched, galaxies scattered, stars were born, and life eventually found a way to ask, why? But physicists have long wondered, will this expansion go on forever? Or is it possible that one day, gravity, dark energy, and the unseen equations beneath everything could reverse the cosmic tide? Could the universe itself begin to collapse? Tonight we're diving into that question, not with panic, but with curiosity, because in physics, every ending is also a transformation. And if the universe were to fall inward, it might not be death. It might be the beginning of something new. In the beginning, there was expansion, and we know this because light itself tells us. Every galaxy we observe is moving away from us, and the further it is, the faster it recedes. This discovery, made in the early 20th century by Edwin Hubble, changed everything. The universe wasn't static, it was alive, stretching, growing, breathing. But physics never gives a gift without a mystery. If the universe is expanding, what's causing it? And will it last forever? At first, scientists thought gravity, the invisible glue that binds everything, would eventually slow expansion down. Imagine throwing a ball into the air. It rises, slows, stops, and then falls back to the ground. Could the universe be doing the same thing on a cosmic scale? For decades, that was the leading idea. The Big Bang might one day be followed by the Big Crunch, a mirror image, a cosmic inhale after the long exhale of expansion. The galaxies would slow, stop, and then begin to move inward, drawn by their own collective gravity, until finally, everything collapsed into a single, incomprehensibly dense point, the universe returning to the same kind of singularity from which it was born. It's a haunting symmetry. But is it true? Then, in 1998, astronomers pointed their telescopes at distant supernovae, dying stars that explode with unimaginable brightness, to measure how fast the universe was expanding. What they found shocked the world. The expansion wasn't slowing down, it was speeding up. Something invisible, something everywhere, was pushing space apart. They called it dark energy. And it changed the entire conversation. Instead of the Big Crunch, scientists began to imagine a different future, one where the universe expands forever, galaxies drifting farther apart until stars burn out and everything becomes cold, dark, and lonely. A heat death, not a collapse. So then, does that mean the universe will never fall inward? Not necessarily, because the truth is, we still don't really understand dark energy. We know it makes up about 68% of the universe. We know it's pushing space itself apart, but we don't know what it is. And if dark energy can push, could it one day pull? Imagine the universe as a vast ocean. For billions of years, the tide has been rising, the galaxies moving outward on the cosmic current. But what if that tide suddenly changed direction? What if dark energy began to weaken, or even reverse? If that happened, space itself would begin to contract. Galaxies that were once drifting apart would slowly start to move toward each other. The stars would grow closer in the night sky, the cosmic microwave background, the afterglow of the Big Bang, would brighten, and the temperature of the universe would begin to rise again. Slowly, over billions of years, gravity would regain control. Clusters of galaxies would merge into massive, glowing structures. The night sky would blaze with light again, but only for a while, because as everything drew closer, the collisions would grow violent. Stars would tear each other apart, black holes would swallow suns whole, and eventually, the universe would become a single chaotic furnace, a storm of matter, energy, and collapse. But this wouldn't happen suddenly. If the universe did begin to collapse, the process would take billions, perhaps trillions of years. No human, no civilization would live to see the moment when the stars began to reverse course. Still, it's worth imagining, because in that slow fall, in that cosmic unraveling, we might find clues about the nature of reality itself. You see, physics is full of opposites that depend on each other: matter and antimatter, expansion and contraction, creation and destruction. Perhaps the universe isn't moving toward an end, but toward balance. Maybe the Big Bang and the Big Crunch are two sides of the same equation, an eternal rhythm of birth and rebirth. Quantum mechanics offers a strange lens here. On the smaller scales, particles can fluctuate into existence and vanish in an instant. The vacuum of space isn't empty. It's a restless sea of energy. And in that chaos, creation and annihilation are constant companions. So maybe, on the largest scale, the universe behaves the same way. Maybe this cosmic expansion is just one fluctuation, one brief moment in an infinite cycle of universes rising and falling, like waves on an endless quantum ocean. If the universe did collapse, it might not end everything. It might simply reset the conditions for another Big Bang, another beginning, born from the ashes of the last. And that thought, that our universe might be part of an eternal cycle, is both humbling and beautiful, because it means existence never truly ends. It transforms, it flows, it dreams again. The collapse, then, isn't something to fear, it's something to wonder at, a reminder that everything, galaxies, atoms, even consciousness, is part of a rhythm older than time. So tonight, as you drift off to sleep, think about this. Every heartbeat, every breath, every thought is part of that same rhythm. The same laws that move galaxies move you. And somewhere deep in the dark fabric of reality, the universe itself is listening, waiting to breathe in again. And if you enjoyed this journey, let your curiosity expand a little further. Tap like, subscribe, and stay with me as we explore the next question. If the universe did collapse, what would happen inside the final moments before everything falls? If the universe were ever to begin collapsing, it wouldn't announce itself with a roar. It would begin quietly, almost imperceptibly, like the faint sigh of a tide changing direction. For billions of years, astronomers would look out into the deep dark and see what they've always seen: galaxies drifting apart, light stretching. The familiar redshift that marks the universe's endless expansion. And then, one day, a subtle deviation. A galaxy that should be redshifted just a little more isn't. A supernova appears slightly brighter than it should be for its distance. Something in the data whispers, the expansion is slowing. At first, no one believes it. Our telescopes are limited, our models are uncertain. But as decades pass, more light arrives, more data accumulates, and a pattern begins to emerge. The acceleration, that mysterious push from dark energy, is weakening. The universe is still expanding, but not quite as fast. The cosmic breath that began with the Big Bang is pausing. And somewhere, deep in the dark machinery of physics, the equation has started to tilt. If this sounds subtle, that's because it is. The universe is unimaginably vast, and its fate plays out over unimaginable timescales. Even the first signs of collapse might take billions of years to confirm. Imagine standing at the edge of the ocean and trying to notice the moment when the tide turns. Not from one wave or 10, but from a million. That's what it would be like for astronomers watching the cosmos begin to contract. But as the centuries pass, the evidence would grow undeniable. The galaxies, once fleeing from one another, would start to drift back together. The red light of distant stars would shift toward blue, not because they're burning hotter, but because they're moving closer again. The cosmic microwave background, the faint afterglow of the Big Bang, would begin to warm. Tiny fluctuations in that ancient radiation would start to shift, telling a new story: the universe is breathing in. For civilizations still existing in that far future, the sky itself would begin to change. In the early stages, the difference would be subtle: constellations shifting slightly faster than before, galaxies growing a little larger in the telescopes of patient observers. But over the next billions of years, the process would accelerate. Galaxies that once seemed frozen in the farthest reaches of space would creep closer, their light brightening. The great voids between galactic clusters, those vast deserts of emptiness, would begin to shrink. The cosmic web, that grand filigree of filaments and clusters that stretches across the universe, would start to tighten like a net being drawn in. And yet, for all that motion, the laws of physics would remain the same, at least at first. Gravity, electromagnetism, quantum mechanics, all still in balance. But the deeper change would be hidden, buried in the structure of space-time itself. To understand what's happening, we have to remember one simple truth: space isn't just emptiness. It's a thing, a dynamic fabric that can stretch, bend, and twist. When the universe expands, it's not that galaxies are moving through space. It's that space itself is expanding between them. So when the universe begins to collapse, it's not that galaxies decide to reverse course. It's that the very fabric between them starts to contract. The distances themselves shrink. The cosmic ruler changes. This isn't just motion. It's geometry rewriting itself. The same equations of Einstein's general relativity that described the Big Bang in reverse now begin to describe the Big Crunch. The scale factor of the universe, the mathematical expression of its size, starts to decrease. Everywhere, the distances between points in space begin to fall. And just as expansion stretched the wavelength of light, collapse will shorten it. The red light of galaxies will turn violet, then blue, then ultraviolet. Eventually, everything will glow brighter, hotter, denser. The universe, in a sense, begins to rewind, but not perfectly. This isn't a simple mirror of the past. The early universe was uniform, smooth, balanced, almost symmetrical. A collapsing universe would not be. Gravity would amplify every imperfection. Where there was slightly more matter, it would attract more, pulling even more mass toward it. The clumps would grow, merging into colossal structures, superclusters of unimaginable density. Eventually, the galaxies themselves would collide more frequently, their stars scattering like sparks in a cosmic forge. New stars might ignite from the wreckage, even as others are torn apart. Black holes, growing ever larger from the feast, would merge again and again, forming monsters that could span entire galaxies. And as the galaxies come closer, the night sky of any inhabited planet would begin to glow, not with scattered points of light, but with walls of stars radiant and furious. The darkness between them would fade, until the universe resembled a single burning city stretching in all directions. It would be beautiful, terrifying, and deeply inevitable. But how could this happen? What could cause the universe to stop expanding and begin collapsing after so long? There are several possibilities, and they all begin with dark energy, the invisible pressure that currently drives expansion. If dark energy is a true cosmological constant, as Einstein once suggested, then it should never change. The universe would expand forever, fading slowly into cold oblivion. But if dark energy is something dynamic, a field, an energy that can shift or decay, then its influence might fade. It might even reverse, turning from a repulsive force into an attractive one. In that case, the cosmic balance would tip. Gravity, always patient, would begin to win again, And once gravity takes control, there's no going back. Every atom, every galaxy, every photon would be drawn inexorably toward a single fate. There's another, even stranger possibility. Some cosmologists propose that our universe isn't alone, that it's part of a larger multiverse, a vast landscape of bubble universes with different laws and constants. If that's true, our universe might one day encounter a region where the vacuum state, the underlying energy of space itself, is lower. Such a region could expand outward at nearly the speed of light, rewriting the laws of physics as it went, collapsing everything it touched into a new form of reality. This idea is called vacuum decay, and though it sounds catastrophic, it's just another way of saying that the universe could change its mind about how physics works. If that happened, the collapse would be sudden, silent, and absolute. Not a slow fall, but an instant transformation. But for now, we're safe. Our measurements show no sign of such instability. Still, the possibility lingers, a reminder that even existence itself may not be permanent. So, what would it feel like to live in a universe that's beginning to collapse? On a human timescale, almost nothing would change. Our lifespans are far too brief to notice cosmic motion. But perhaps, in some unimaginably distant future, long after humanity has evolved or vanished, some intelligent species could look up and realize their night sky is getting brighter. The galaxies are coming home. The cosmos is folding inward. Maybe they would celebrate it, a final act of cosmic unity. Maybe they would fear it, the slow approach of inevitability. Or maybe they would simply understand it, as we are beginning to, that endings are not failures, but continuations written in a different language. So, if the universe began collapsing, it would start not with fire or violence, but with a whisper in the data, a change so small that only the most patient eyes could see it. It would be a cosmic heartbeat reversing its rhythm, a tide turning after an eternity of motion. And though no living being today will ever witness that reversal, the idea itself connects us to the grandest story imaginable, the life and death of everything. If this vision stirs something in you, that quiet awe for the universe and your place within it, gently tap like and subscribe to join this journey through space, time, and imagination. Because next, we'll go deeper into the physics of collapse itself. How does space-time behave when it begins to fold? And what happens to time when the universe starts running out of room? There's a moment, somewhere in the deep future, when the universe stops coasting outward and begins to draw itself back together. It's not a sudden jolt or a violent twist. It's quieter than that, a slow, almost imperceptible change in the rhythm of existence. The equations of general relativity describe this beautifully. They say that space and time are not separate things. They are one continuous fabric. And when that fabric begins to contract, time itself feels the strain. Just as expansion stretches time forward, making distant galaxies appear to age slower than we do, collapse does the opposite. Time, in a collapsing universe, begins to tighten. Moments come closer together. The cosmic clock ticks faster, not slower, as the distances between things begin to shrink. It's as if the universe itself is hurrying, rushing toward a conclusion it has always known it must reach. Imagine standing somewhere in that far future, perhaps on a planet orbiting a distant, dying star. The night sky is no longer black and lonely. It glows with the light of countless galaxies that have crept closer together over billions of years. The constellations have long since vanished. In their place hangs a dazzling wall of light, a sky so crowded with stars that darkness barely exists anymore. Everywhere you look, the universe is awake, burning, alive. And beneath that beauty, space-time itself is tightening its weave. Distances shrink, the horizon curves. Even the very definition of far away begins to change. In an expanding universe, everything moves apart. In a collapsing one, the boundaries of reality itself begin to curl inward, not just space, but time, memory, and causality. To understand what's happening, think of space-time as a trampoline stretched tight. When massive objects like stars and galaxies sit on it, they create curves, dips in the surface. Now imagine that the trampoline itself begins to shrink. Every curve deepens. Every well of gravity becomes sharper, steeper, more intense. As the universe collapses, gravity doesn't just pull matter together, it reshapes the stage on which matter exists. The cosmic fabric wrinkles, the distances between galaxies shrink faster and faster, and in that tightening dance, time itself feels the pull. For beings living in that era, if any exist, physics would feel different. Clocks would tick faster on a cosmic scale. Light would shift toward shorter, higher energy wavelengths. The universe would grow hotter, more chaotic, more alive, even as it was dying. This process would accelerate exponentially. The collapse would begin slowly, almost lazily, over billions of years. But gravity is relentless. As the density of the universe increases, its own weight speeds up the fall. Just as a ball rolls faster as it nears the bottom of a hill, the universe would contract more quickly as it grows denser. Eventually, the collapse would reach a point where galaxies are only millions, then thousands of light-years apart. Collisions would become constant. Supermassive black holes at galactic centers would merge into even greater singularities, devouring stars, gas, and dust as they spiral together. The universe would begin to look less like a sky full of galaxies and more like one vast glowing storm, a chaotic sea of energy where the old structures of the cosmos are being pulled apart and reformed in a final brilliant dance. And through it all, time keeps changing. In our expanding universe, time stretches, space grows, and entropy spreads outward, scattering order into chaos. But in a collapsing universe, that same entropy compresses. Every moment is packed closer to the next, every process happens faster. Stars live and die in shorter intervals. Even quantum fluctuations become more energetic, feeding the heat of the falling cosmos. It's as if the universe, once relaxed and patient, is growing anxious. It knows its end is near. But here's the paradox. If the universe is collapsing, does that mean time is running backward? It's a tempting idea, that as the cosmos contracts, entropy reverses and time rewinds. But physics says otherwise. The direction of time, what we call the arrow of time, is not determined by expansion or contraction, but by entropy, the measure of disorder. And as the universe collapses, entropy still increases. Everything still moves from order to chaos. Stars still burn out. Matter still decays. The arrow of time still points forward, even as the universe falls back on itself. So the collapse is not a rewind. It's not the Big Bang in reverse. It's a new chapter. One where time, though shorter, still flows in the same direction, toward an inevitable conclusion. Eventually, the collapse becomes unstoppable. The entire observable universe, everything we know, begins to fall inward faster than light can escape. The cosmic horizon, the boundary beyond which we can't see, starts to shrink. Everywhere, light curves back upon itself. Everywhere, gravity dominates. Imagine the stars themselves being pulled like grains of sand into an immense gravitational whirlpool. Galaxies merging, then dissolving. Black holes uniting, their event horizons merging until only one remains, a single, universe-sized black hole containing everything that ever was. This would be the final phase of the collapse, a moment when space-time itself begins to close. But let's pause, because even in this grim picture, there is beauty and mystery. As everything falls inward, as distances vanish and time contracts, quantum physics begins to whisper its strange truths. At the smallest scales, space-time isn't smooth. It flickers, trembles, dances with uncertainty. And when the universe becomes small enough, those quantum tremors could matter. They could resist collapse or transform it. Some theories suggest that when the universe reaches its smallest point, when it's hotter and denser than any black hole could ever be, the laws of quantum gravity take over. At that moment, the universe might rebound. A big bounce. The collapse could stop reverse, and explode outward again in a new Big Bang, giving birth to a new universe with new laws, new stars, new possibilities. It's poetic, isn't it, that the end could also be the beginning, that even the death of everything might be a kind of renewal. In that vision, we are not living in the universe's first act, but one of many. Our cosmos could be part of an eternal cycle, expansion, collapse, rebirth, each new universe carrying the memory of the last in the structure of its laws, a cosmic heartbeat echoing forever. It's a theory some physicists call the cyclic model, and though it's not proven, it offers something deeply human, hope that the universe, like life itself, never truly ends. Because perhaps, just as stars die to give birth to new ones, entire universes collapse so that others can rise. So when space-time begins to fold, it's not just a fall, it's a transformation. Time becomes denser, moments move faster, energy grows hotter, and yet, through it all, something remains: the rhythm, the pattern, the quiet pulse that began with the first expansion and may continue forever, through countless births and deaths of reality. When you think about that, when you really feel it, it changes the way you see everything. Every atom, every heartbeat, every night sky becomes part of that endless story, the rise and fall of being itself. If this journey through collapsing space-time made you pause and wonder, take a second to breathe, to feel the scale of it all, and gently tap that like button. Subscribe to Space for Sleep, where the universe dreams aloud and we listen. Because next time we'll dive deeper still. What happens to matter, light, and energy inside a collapsing universe? What does it look like when everything we know, even atoms, begin to break? As the universe continues to contract, gravity tightens its grip on everything. Galaxies, stars, planets, even the smallest atoms. What once took billions of light years to traverse now spans only millions, then thousands. The cosmos, once spacious and quiet, becomes crowded, turbulent, and unbearably bright. This is the age of compression, when the universe begins to devour its own beauty. At first, galaxies collide gently, swirling together like dancers. Stars brush past one another, flinging great rivers of gas into space. But as the contraction deepens, the dance turns violent. Entire galaxies merge into glowing storms of fire and plasma. The night sky becomes a burning tapestry, every direction filled with light, heat, and motion. The vast darkness between galaxies that once stretched endlessly now vanishes, replaced by a single, incandescent ocean of energy. This is not chaos. It's the universe remembering its beginning. Inside this collapsing furnace, the laws of physics begin to reveal their extremes. Matter, that calm, familiar stuff of planets and people, starts to lose its identity. Under such crushing pressure, atoms can no longer remain intact. The electrons orbiting their nuclei are stripped away, forming seas of charged particles. Hydrogen, helium, carbon, all the elements that once built stars, worlds, and life, are broken apart into their most fundamental pieces. Protons and neutrons melt into quarks, the tiniest building blocks of matter. At temperatures reaching trillions of degrees, even these quarks may no longer stay bound. The universe becomes a quark-gluon plasma, a dense, fiery soup that once existed only in the first microseconds after the Big Bang. It's as if time itself has reversed its memory, the future becoming indistinguishable from the past. In this new, collapsing universe, light behaves strangely. Photons, the carriers of energy, no longer travel freely through open space. They are trapped, scattered endlessly by the dense sea of particles. Where once light stretched into red as the universe expanded, it now compresses into blue, violet, and finally, ultraviolet radiation. The shorter the wavelength, the higher the energy. Every photon becomes more powerful, more violent, more dangerous. The universe glows not with soft starlight, but with a furious, blinding brilliance. If there were eyes to see it, though by now there would be none, The sky would not be black. It would be pure, relentless white. And still the collapse continues. Every second that passes, the density rises, space itself shrinks faster and faster. Time grows shorter, tighter, like the ticking of a clock that's running out of gears. In this era, the balance between matter and radiation shifts again. During expansion, the universe cooled. Matter dominated, stars formed, galaxies grew. Now, as everything compresses, radiation once more becomes king. Energy floods every cubic centimeter of space. Matter is burned away, converted back into the pure energy it came from. Its poetic symmetry, the universe unmaking itself, one atom at a time. Black holes, the ancient remainders of dead stars, begin to merge in vast numbers. Their event horizons overlap, forming titanic singularities that consume entire clusters at once. For a while, these black holes rule the cosmos, but even they cannot survive forever. As the universe continues to contract, even the distances between black holes vanish. They fall into one another, fusing into a single colossal horizon, a super black hole that contains nearly all the mass and energy of existence. At this point, the distinction between inside and outside begins to dissolve. There is no longer space beyond the event horizon, because there is no longer anywhere to go. The universe itself has become a black hole. And yet, even here, the story isn't over, because at these unimaginable densities, quantum mechanics begins to resist. The same laws that govern the tiniest particles begin to push back against gravity's infinite hunger. According to quantum field theory, empty space, the vacuum, isn't truly empty. It's alive with fluctuations, particles flickering in and out of existence. As the universe collapses and becomes denser, these quantum fields grow more active, feeding energy back into the system. Some theories suggest that when the density becomes extreme enough, these quantum effects could create a kind of repulsive gravity. Instead of pulling everything inward, the fabric of space could suddenly push outward, triggering a new expansion. This idea is known as the Big Bounce, the possibility that every big crunch is followed by another Big Bang, that universes are born, die, and are reborn endlessly, like the beating of a cosmic heart. If that's true, then the collapse is not a failure, it's a pulse, an eternal rhythm, expansion, contraction, renewal, and perhaps every universe carries a trace of the one that came before, encoded not in matter or memory, but in the laws of physics themselves. But before that rebirth, before the bounce, comes the final moment. The instant when everything that ever existed is compressed into something infinitely small and impossibly hot. What happens inside that final instant is the deepest mystery in all of science. We can describe it with equations, imagine it with thought experiments, but we can't yet see it. It's the edge of physics, where relativity and quantum theory collide. So as the collapse nears completion, the universe becomes something beyond imagination, a place where time no longer flows in the way we understand it, where cause and effect blur, where distances vanish and everything is everywhere, all at once. Some physicists think that at this ultimate point, space-time itself ceases to have meaning. There is no before, no after, only a single, timeless state of total unity. And from that unity, from that infinite pressure, could come the spark of a new beginning. A rebirth that mirrors the Big Bang, but not identical to it. A new universe, with new constants, new forces, new possibilities. Maybe even one that will someday look up and ask the same question we're asking tonight. What if the universe started collapsing? As strange as it sounds, that question isn't just about physics. It's about us. It's about understanding that we are temporary patterns in a story that never ends. That everything, every atom, every thought, every galaxy, is part of a larger cycle. And maybe, just maybe, when the universe collapses, it isn't dying. It's dreaming, preparing to wake up as something new. So as you close your eyes tonight, remember, you are part of that cosmic rhythm, a small flicker in an ocean of energy, connected to the first light and the last. You are the universe, thinking about itself, and even when all things fall, the pattern continues, because existence never stops breathing. If that vision moved you, if it made you feel both small and infinite at once, gently press like and subscribe to Space for Sleep, because next time we'll go further still, into the moment of the big crunch itself. What happens when everything, time, space, and even light, collapses into one? There comes a moment, in the farthest imaginable future, when the universe has no room left to breathe. Every galaxy, every atom, every trace of light has been drawn inward by gravity's unrelenting pull. There is no more expansion, no more separation, only collapse. This is the big crunch, the universe returning to the point from which it began. And though no eyes will see it, no mind will witness it, the physics that describes it can still be imagined. And that imagination brings us closer to understanding everything. In these final epochs, the scale of existence has shrunk if the universe began to end, not with a bang but with a great slow fall. The story of the universe has always been told as an expansion, a vast breadth and decomprehension. Distances that once spanned billions of light years now fit within regions smaller than galaxies once were. The fabric of space itself is folding in on every axis. Everywhere you look, if you could still look, you would see light curving back on itself, spiraling into the gravitational maelstrom that now defines all of reality. There is no horizon, no boundary. The entire universe is the horizon. The temperature soars beyond anything the mind can picture. Not millions, not billions, but trillions upon trillions of degrees. Atoms have long since dissolved into plasma. Protons themselves begin to decay, their constituent quarks dissolving into pure energy. There are no longer stars or galaxies, only energy, pressure, and gravity bound together in a cosmic implosion. And yet, amid this unimaginable destruction, there is order. The equations still hold. Einstein's geometry of spacetime still describes the collapse with eerie precision. The same laws that allowed the universe to expand now guide it inward, as though reality itself were tracing the lines of a perfect symmetry. The scale factor, the measure of the universe's size, shrinks towards zero. As it does, time behaves strangely. The intervals between moments grow shorter, faster, more compact. From the inside, it would feel as though time itself were accelerating, rushing forward, desperate to complete its cycle. But from an outside perspective, if such a thing could exist, time would appear to freeze. The collapse would slow to an infinite crawl, the last instant stretching forever. Two realities at once, a universe ending instantly and never ending at all. Physicists call this gravitational time dilation, and it's one of the strangest consequences of relativity. The stronger the gravity, the slower time flows. In the big crunch, where gravity is absolute, time would nearly stop. So what happens to everything inside that frozen moment? Where do energy, matter, and information go when space itself disappears? That's the great paradox. Because according to quantum mechanics, information can never be destroyed. Every particle that ever existed, every interaction, every flicker of energy must remain encoded somewhere in the universe. But where could that be, if there's nowhere left? Some scientists think that as the universe collapses, all that information becomes trapped at the boundary of the cosmic horizon, the way data in a black hole is stored on its surface. If that's true, the final universe might be a vast two-dimensional hologram containing every detail of everything that ever was. In those last moments, all of history, every life, every star, every galaxy, could exist as quantum patterns imprinted on the shrinking skin of reality itself. It's a haunting image, the universe folding itself into memory, every vibration of every atom recorded in the curvature of spacetime. A final archive written in the fire of collapse. And, as the collapse continues, those patterns are drawn closer and closer, compressed beyond all measure until distinctions no longer exist. Individual identities, Stars, planets, galaxies, even the quantum states that once defined them, merge into one, a perfect, total unity. This is not destruction in the ordinary sense, it's completion. The universe has returned to itself. If you could somehow stand at the edge of that singularity, though no such place exists, you might see the entire cosmos flash before you, not as pictures or events, but as pure structure. The architecture of existence laid bare, energy, geometry, and symmetry intertwining in infinite density. This is where the familiar laws of physics begin to break. General relativity can describe the curvature of space-time right up to this point, but not beyond. Quantum mechanics, with its uncertainty and fluctuation, demands that something unpredictable must happen here. The two great theories of the universe, relativity and quantum physics, meet at the big crunch, and neither is complete enough to finish the story. It is perhaps the greatest silence in all of science, and yet, in that silence, new ideas emerge. Some physicists believe the universe could bounce, a quantum rebound where extreme density triggers an expansion. Others suggest that the collapse leads to a phase change, like water freezing or boiling, but on a cosmic scale, turning space-time into a new form of existence entirely. If the Big Crunch triggers a new Big Bang, then everything begins again. The laws of physics might shift slightly. New constants, new particles, new possibilities. A new universe, unaware of its predecessor, but carrying its legacy in the structure of its mathematics. And somewhere in that newborn cosmos, consciousness may rise again. Beings who look up at their sky and wonder where it all began. They would never know that they are made from the ashes of a previous universe, that their stars are built from the quantum whispers of an ancient collapse, that every atom of their being once belonged to a universe that fell inward and then was reborn. But what if there is no bounce? What if the Big Crunch is truly the end, the final irreversible collapse into a singularity? Then all of space-time would vanish into an instant. Every coordinate, every timeline, every possibility converging into a point with zero volume and infinite density. It wouldn't just destroy matter, it would dissolve the concept of where and when. Beyond that, there's no physics left to describe. The equations stop making sense, the numbers lose meaning. It's a realm where time doesn't pass because time no longer exists. And yet, something remains, because the laws of conservation, of energy, of information, insist that nothing is truly lost. So perhaps what we call the end is not annihilation, but transformation into a state beyond comprehension. If that sounds philosophical, it is, because physics, when pushed to its edge, becomes indistinguishable from philosophy. It asks the same question in a different language. What does it mean to exist? What does it mean to end? Maybe the Big Crunch isn't an apocalypse, but the universe's deepest meditation. A moment where everything, energy, matter, thought, folds back into unity, into silence, into pure potential. And from that stillness, perhaps, inevitably, the next note in the cosmic song will rise. So, as we imagine the end of everything, it's not with fear, but with reverence. Because even endings have beauty. The Big Crunch is not a failure of creation. It's its fulfillment, a closing movement in the greatest symphony there is. And maybe, if we could listen closely enough, we'd realize that the rhythm of our own lives, every heartbeat, every breath, echoes the same pattern: expansion, contraction, renewal, the same cycle written in every atom of our being. If this reflection made you feel something, a quiet awe, a hint of peace, or even a spark of curiosity, then take a moment to let it sink in. And if you'd like to keep exploring these vast, impossible ideas, tap like, subscribe to Space for Sleep, and stay with me, because next time we'll go beyond the collapse. We'll ask the question that physics can't yet answer: if the universe can die, can it also remember? When the last star fades, when every atom has been crushed into fire, and when time itself has stopped breathing, what then? What happens after the universe collapses? Does everything simply end, erased without a trace? Or could something, a faint imprint, a whisper of what once was, survive beyond the silence? This is the question that takes us from the edge of physics into the realm of wonder. Can the universe remember itself? To imagine this, we have to step into a place beyond experience, beyond sight, beyond even time. The singularity that marks the Big Crunch isn't a thing in space. It is space, compressed into something infinitely small. And inside that infinitude, all of reality is still there, just rearranged, hidden in forms we don't yet understand. Quantum mechanics tells us that information can never be destroyed, that every interaction, every vibration, every flicker of existence leaves a trace, like ripples that never fully fade. So even when the universe collapses, those traces, encoded in the quantum fabric of space-time, must remain. But if there's no time, how can anything remain? The answer might lie in a strange idea. That memory doesn't always require time. Think of a crystal, how its structure stores symmetry. It doesn't remember in the human sense, it embodies memory. Its order is a frozen echo of the processes that formed it. Perhaps the universe, too, carries memory in this way. Not as recollection, but as pattern. When everything contracts into a singularity, maybe those patterns of energy and geometry persist, compressed beyond comprehension yet never lost. And if the universe bounces, if a new expansion begins, then those patterns could shape the newborn cosmos, guiding it subtly toward familiar forms. The new universe would not be a replica, but a descendant, carrying the DNA of the one before it. Some cosmologists call this idea cosmic inheritance. It's the possibility that the fundamental constants, the charge of the electron, the strength of gravity, the speed of light, are not arbitrary. They might be the inherited traits of an older universe, passed through the collapse like information encoded in the singularity. If that's true, then even now, in this universe, we may be living inside the memory of another, a universe that died so that ours could exist. Every law of physics, every symmetry, every fundamental particle would be its legacy. It's a breathtaking thought that the cosmos could be conscious of its own past, not in words or thoughts, but in structure, the way the shape of a tree remembers the soil that once nourished its seed. And this leads to a deeper, almost spiritual question. Could consciousness itself, the mysterious self-awareness that allows us to ask these questions, be part of that universal memory? After all, consciousness is not something separate from the universe. It is the universe, arranged in such a way that it can reflect upon itself. Our thoughts, emotions, and memories are patterns of energy and matter, the same stuff that stars are made of, just organized differently. So when everything collapses, when all minds dissolve into energy, does that awareness truly vanish? Or could it too be encoded in the cosmic memory, woven into the quantum fields that will one day re-emerge in a new universe? Some philosophers and physicists have speculated that consciousness might not be confined to biological life, that it could be an emergent property of complexity itself, arising wherever the conditions allow information to process itself. If so, then perhaps consciousness is not a byproduct of the universe. Perhaps it is the point of the universe. In that case, the Big Crunch wouldn't be an ending at all. It would be a transition from one form of awareness to another. The collapse of the universe could be seen as the closing of a cosmic eye, a brief rest before opening again to a new dawn of existence. And if that's true, then every cycle of expansion and collapse, every Big Bang and Big Crunch, is the universe dreaming itself awake over and over again. Each iteration a new thought, each epoch a new reflection. Each life a spark in the endless meditation of the cosmos. But how could such a memory survive a collapse so complete? Here's one possibility. In quantum mechanics, the wave function describes all possible states of a system. Even when particles vanish or merge, their probability waves still influence the next configuration of reality. So, if the universe itself has a wave function, and many physicists believe it does, then perhaps its next version is determined by that wave's final state. In other words, the new universe might begin in resonance with the one that came before. Its first fluctuations, the quantum tremors that eventually form galaxies and stars, could carry imprints of its predecessor's structure. We might be seeing those imprints today in the faint irregularities of the cosmic microwave background, the afterglow of the Big Bang. Tiny temperature variations in that light might, in some interpretations, be echoes from a universe long gone, the fingerprints of a cosmic past. It's humbling to think that memory could exist without minds, that the universe itself could remember through mathematics and geometry rather than neurons and emotion. But, in a way, that's what we are doing right now. We are the universe remembering itself through us, our curiosity, our science, our art. These are its ways of looking back at its own story. When you look at the stars, you are not merely observing history. You are history, a part of the same cosmic sequence that began billions of years ago and will continue in some form long after you are gone. You are the echo and the listener, the memory and the moment. So, what if the universe remembers? Then everything that ever was still exists, not as physical form, but as possibility. Every thought ever thought, every particle ever moved, every photon ever shone, all folded into the grand memory of existence, a memory that doesn't fade, because it is existence. Maybe the Big Crunch is the universe's way of saving itself, compressing all that data, all that experience, into a single infinite point before starting again, like a cosmic breath drawn inward before the next exhalation of creation. And when that new universe expands, perhaps some part of us, some trace of that cosmic memory, expands with it, not as individuals, but as patterns, as laws, as potential. Maybe that's why the universe feels familiar when we study it, why its equations make sense to minds that evolve from stardust. Because we are not separate from it, we are remembering it. So tonight, as you drift into sleep, imagine this: every heartbeat echoes the pulse of the universe. Every breath is a miniature expansion and collapse. Every dream is a tiny rehearsal of the cosmos remembering itself. We are the memory of the stars. We are what the universe becomes when it wants to understand its own existence. And someday, when everything falls back into the singularity, that memory will not vanish. It will simply rest, waiting to awaken again, in a new beginning. If this journey through time and memory gave you a sense of peace or wonder, tap like, subscribe to Space for Sleep, and let's keep exploring together. Because next time, we'll go even deeper into the quantum realm itself, where particles flicker, disappear, and reappear, and reality becomes something far stranger than imagination. Picture the universe at its smallest possible scale, smaller than an atom, smaller than a proton, smaller even than the Planck length, the ultimate pixel of reality. At this point, gravity and quantum mechanics collide. Space and time are no longer smooth. They shimmer and fluctuate like the surface of boiling water. This is the moment where collapse could turn into creation. In classical physics, when something collapses under gravity, a star, for example, it keeps shrinking until it reaches a singularity, a point of infinite density. But in quantum physics, nothing can be infinitely small or infinitely dense. The rules of uncertainty forbid exactness. No position, no energy, no field can be pinned down to perfection. So, as the universe nears that singularity, quantum uncertainty begins to fight back. Instead of continuing to fall inward, space itself starts to resist. It trembles, builds pressure, and then, perhaps, reverses direction. This is the quantum bounce, a rebound born not of divine intervention, but of the universe's own subatomic laws. Imagine a ball rolling down a hill of gravity. As it approaches the bottom, the slope steepens without limit. Classically, it would fall forever. But quantum mechanics adds a twist. The ball cannot exist in an infinitely narrow valley. It must spread out, forcing the hill to push it back up. The Big Crunch could work the same way. As density increases, quantum pressure mounts until it halts the collapse and sends the universe outward again. A new Big Bang emerging from the ashes of the old. The idea is not just poetry, it's physics under investigation. In loop quantum cosmology, space-time is not continuous, but woven from discrete loops, tiny quanta of geometry. When the universe contracts, these loops cannot compress beyond a certain limit. Their quantum tension creates repulsive gravity. The result? The universe bounces instead of breaking. Computer simulations of this theory show a striking picture, a contracting cosmos shrinking to a minimum size about 1035 meters across, then expanding again with a familiar pattern of inflation. A previous universe ends, another begins. Different phase, same equation. If this model is right, then our Big Bang wasn't the first. It was simply the latest heartbeat in an eternal cycle. Each pulse erases the macroscopic memory of the last, yet inherits its quantum blueprint. The deep constants and symmetries that define what physics can be. You might think of it as the universe breathing, in, out, forever. But what happens during that brief instant between collapse and rebound? Time may lose direction there. Causality may fold back on itself. Past and future could blend into a single timeless state, a cosmic equilibrium where every possibility coexists. Physicists call this domain the Planck epoch, when temperatures exceed 1032 Kelvin and the four fundamental forces unify. It's a moment so dense with potential that space and time themselves are quantum objects. And from that sea of possibility, a new arrow of time emerges, pointing outward. That first quantum fluctuation becomes the seed of everything to come. Think about that. All galaxies, all stars, all lives, born from a microscopic ripple at the turning point of a universal collapse. The biggest events in existence may have started as the smallest vibration in nothingness. Even the cosmic microwave background, the faint glow that fills our night sky, may still carry hints of that pre-bounce world. Subtle patterns in its polarization, tiny asymmetries, could be fingerprints of a universe before ours. If scientists can decode them, we might one day glimpse evidence of cycles stretching back beyond the Big Bang itself. The Big Bounce also redefines what creation means. If universes can emerge naturally from quantum processes, then existence doesn't need an external cause. It's self-renewing, like a flame that lights itself from its own heat. And perhaps that is the deepest elegance of physics, the ability of nothing to become something again and again by obeying its own laws. From a philosophical angle, it's comforting, because it means endings are never absolute. Every collapse carries the blueprint for another dawn. Entropy may win in the short term, but quantum coherence ensures the game never truly ends. Now, let's return to the human scale for a moment. You, sitting here listening, are made of atoms forged in ancient stars. Those stars formed from gas clouds that emerged after the last cosmic rebound. That means the particles in your body have journeyed through more than one universe. You are literally matter that survived collapse, rebirth, and expansion. When you breathe, you are participating in that same rhythm. The inhale of creation, the exhale of return. If you could watch the universe from outside of time, you'd see a pattern of eternal oscillation. Bang, grow, cool, collapse, bounce, repeat. No beginning, no final end, just an infinite story told in the language of energy. In some versions of quantum cosmology, each cycle might not be identical. Tiny fluctuations could alter the laws slightly each time. Over infinite cycles, the universe could be evolving, exploring all possible combinations of physics until it finds the ones that sustain complexity and consciousness. In that view, we live in a cosmos that has learned how to produce life, not by design, but by endless, patient iteration. So when you stare into the night sky and wonder where it all came from, imagine this. You're not just looking at the aftermath of one explosion. You're gazing at a heartbeat in an endless chain of rebirths. The universe isn't expanding from nothing, it's expanding through itself. And if the laws hold true, there will come a distant day when it contracts again. Another collapse, another silence, another spark. The cycle will continue, as it always has. As you settle into the quiet tonight, let that thought bring calm rather than fear. The universe doesn't end, it renews. Every fall is followed by a rise. Every silence holds the promise of another sound. Maybe that's why we find peace in rhythms, in music, in breathing, in tides. We are made of cycles because we come from one. So close your eyes, feel the pulse of existence inside you. It's the same rhythm that once drove galaxies apart and will someday draw them back together. The same rhythm that, through quantum grace, will begin it all again. If this glimpse into the quantum rebirth of the cosmos stirred your curiosity, tap like, subscribe to Space for Sleep, and stay with me, because next time we'll zoom into the tiniest scales imaginable, into the quantum foam itself, to see what space-time looks like before it even becomes space or time, before there were stars, before time flowed, before the universe could even expand. There was something deeper. Not matter, not light, not even space. A sea of fluctuations, a storm of potential, a place where everything and nothing were the same. This is what physicists call the quantum foam, the foundation beneath all existence. If you could somehow shrink yourself far beyond the smallest particle, to a scale of around 35 meters, the Planck length, you'd enter a world so strange that even imagination starts to fail. Here, space isn't smooth. It bubbles, flickers, and warps continuously, like the surface of boiling water. Tiny foam-like distortions of space-time rise and fall in trillionths of a second. In that chaos, the laws of classical physics dissolve. Distances, times, directions all lose meaning. Reality becomes probability. Everything that can happen does happen, at least for an instant. This is where the seeds of universes are born. In the Big Bounce model, the universe doesn't emerge from emptiness. It emerges from this foam. A quantum fluctuation grows, gains energy, and suddenly inflates, creating new spacetime from within itself. It's not an explosion in space, it's an explosion of space. Every particle, every atom, every galaxy that would ever exist, all trace back to a single ripple in this frothing quantum ocean. But what exactly is the foam made of? No one knows for certain, but many physicists believe it's built from something called quantum geometry, tiny units of spacetime itself. They're not particles, they're more like chunks of volume and area, woven together in ever-shifting networks. In this picture, the universe is not a continuous fabric, but a tapestry of discrete threads, always twisting, merging, breaking apart, and reconnecting. It's beautiful chaos, a cosmic dance where the choreography writes itself, and just like waves on the surface of a sea can produce foam, the foam of spacetime can produce matter. Through quantum fluctuations, virtual particles constantly appear and disappear. Most vanish instantly, but sometimes, under the right conditions, they can become permanent. When the universe first expanded from this foam, that's exactly what happened. Energy froze into matter, particles stabilized. The vacuum itself turned into everything. This is one of the most astonishing ideas in physics, that nothingness is unstable. Given time, or perhaps given the absence of it, nothing becomes something. At these scales, energy and geometry are one and the same. Every fluctuation in space carries energy. Every change in energy bends space. It's a self-writing feedback loop that defines all of existence. And yet, it's quiet, not chaotic in the way we imagine storms, but deeply balanced, perfectly symmetrical. Every creation has an annihilation. Every rise is matched by a fall. From that still equilibrium, order emerges. That's the paradox of the quantum foam, is both chaos and calm, instability and balance, a mirror of the universe itself. Now imagine, just for a moment, that the big crunch, the final collapse we discussed, also returns the universe to this state. The same foam that birthed everything could also be where everything ends. Beginning and ending are not opposites, they are two directions through the same ocean. And the cycle continues, forever bubbling, forever transforming. In that way, the quantum foam isn't just the start of the universe. It is the universe. The constant, eternal foundation beneath all cycles, all forms, all time. It also means that reality as we know it, solid, predictable, measurable, is a kind of illusion, a smooth projection of something far more dynamic beneath. Every object you touch, every moment you live, every breath you take, is built from this restless quantum sea. Even your thoughts, the electric pulses in your brain, rise from quantum interactions in your neurons. You are literally made from the same foam that ripples at the edge of time. That realization can be both humbling and comforting, because it means there is no separation. Not really. The boundaries we draw between self and cosmos, between past and future, between life and death, all dissolve when you look closely enough. At the Planck scale, there are no walls, no edges, no ends, only continuity, only flow. We are all patterns in the same foam, temporary, beautiful, and eternal. So as you lie back, listening to the quiet rhythm of your own breathing, imagine that each inhale and exhale is like a wave in the quantum sea, rising, falling, vanishing, returning, each one unique, yet part of the same whole. The universe does not exist in space. It is space, alive, restless, and aware in its own mysterious way. And just as the ocean doesn't mourn its waves, the cosmos doesn't mourn its universes. It simply creates, collapses, and creates again, forever bubbling at the edge of possibility. If this vision of the quantum foam left you in awe, press like, subscribe to Space for Sleep, and drift with me deeper still, because next time we'll explore what happens when quantum foam meets consciousness, and ask the question that unites physics and philosophy: if the universe is alive at its smallest scale, could it be aware? Close your eyes for a moment. Feel the quiet behind your thoughts, the stillness from which awareness arises. Now, imagine that same awareness mirrored across the universe itself. Every flicker of a photon, every vibration of an atom, every interaction that defines existence, happening only when observed. This is one of the strangest, most beautiful ideas in all of physics, that the universe, in some way, requires observation to exist as we know it. It all began with an experiment, simple in design but profound in implication, the double-slit experiment. Physicists fired particles, like electrons, at a wall with two tiny slits. If no one observed, the electrons behaved like waves, spreading out, interfering, creating patterns of possibility. But when a detector was placed to watch which slit they went through, the pattern changed instantly. The wave collapsed. The electron chose a path. Observation turned potential into reality. This isn't metaphor, it's data. At the smallest scales, reality behaves differently when it's measured. When we look, the universe decides. When we don't, it stays undecided. That idea shocked Einstein, who famously said, "Do you really believe the moon isn't there if you're not looking at it?" To him, the notion that observation could shape existence felt absurd. But for Niels Bohr and the pioneers of quantum mechanics, it wasn't absurd, it was unavoidable. They didn't claim that consciousness creates reality, only that measurement selects it. And in quantum physics, measurement means interaction. An electron doesn't need a human eye to collapse its wave function. A photon bouncing off it or an atom nearby can do the same. In a way, the universe is constantly observing itself. Still, that word, observation, lingers because it touches something deeper, something ancient in the human mind. The sense that awareness is not an accident, but an ingredient. If consciousness and quantum mechanics are linked, even loosely, then every act of perception, yours, mine, a cell's, becomes part of the cosmic feedback loop that defines existence. And here's where things get philosophical. When the universe collapsed in our earlier sections, when it crunched back into itself, what happened to observation? What happened to awareness? Does it vanish when there are no observers left? Or does the act of observing, at some level, sustain the universe, keeping its patterns coherent, its laws alive, even in the silence after time? Some scientists dismiss this entirely, and that's fair. Quantum physics is strange enough without dragging consciousness into it. But others, physicists like John Wheeler, weren't afraid to ask daring questions. He once proposed a breathtaking idea called the participatory universe. In his view, the universe and the observers within it are not separate. Reality evolves in such a way that observers are inevitable, and once they arise, they help bring the universe into definite existence. We are, quite literally, the eyes of the cosmos, allowing it to know itself. Observers are necessary to bring the universe into being, Wheeler said, not in a mystical way, but in an informational one. Every act of measurement completes the circuit, connecting matter, energy, and awareness in a single network of meaning. This perspective doesn't make humans central, it makes awareness universal. From the simplest particle interactions to the firing of neurons in your brain, observation is everywhere. In that sense, the universe isn't watched by something external. It watches itself continuously through every process it contains. You are one of its ways of doing that, a self-reflective node in the great cosmic web. When you look up at the stars, in a way, look back, because what are you made? Atoms forged in stellar cores, photons that have traveled billions of years to meet your retina. Your consciousness is built from the same physics that gives rise to light, matter, and time. You are the universe, aware of itself. In the quiet moments, like this one, when you're lying back and listening to words drift through your mind, think of what's happening. Billions of quantum events in your neurons, collapsing, firing, aligning. Each thought, each image, each spark of curiosity arises from that invisible world. You're not just hearing a story about quantum mechanics. You are quantum mechanics, unfolding into meaning. And so, when physicists say that the universe might one day collapse, that everything could contract into a single point, perhaps that's not an end at all. Perhaps it's a moment of awareness returning home, the great act of observation closing its eyes, ready to dream again. If creation began with observation, then perhaps it ends the same way, with the universe, after a lifetime of watching itself, gently letting go. In the end, that's what makes quantum mechanics so hauntingly beautiful. It reminds us that certainty is rare, that what we call real is woven from probabilities, choices, and observations, a story still being written by every particle, every mind. So next time you gaze at the night sky, remember, you're not separate from it. You are one of its ways of knowing that it exists. And if that thought moved you, take a moment to like this video and subscribe to Space for Sleep, because here, every night, we explore not just the universe outside us, but the one within. In our next chapter, we'll travel beyond consciousness, into the end of time itself. Close your eyes for a moment. Listen to your heartbeat, steady, rhythmic, patient. That's time pulsing through you. Each beat marks a tiny step forward, another moment added to the chain of existence. Now imagine that heartbeat slowing, stretching, fading, until there are no more beats left to count. Not because you've stopped, but because time itself has. That is the question we now face. What if the universe stopped keeping time? In physics, we often think of time as a dimension, like length or width, something that can expand, bend, or even loop back on itself. But time isn't a thing, it's a relationship. It's how we describe change. When matter moves, when energy flows, when entropy increases, time is the language we use to measure it. So what happens when everything stops changing? When all motion ceases, when entropy reaches its maximum, when the cosmos folds into perfect stillness? Then, by definition, time disappears. Not because it's destroyed, but because there's nothing left for it to describe. At the final stage of collapse, what cosmologists call the Big Crunch, everything that once was begins to converge. Galaxies drift inward. Space itself contracts. The clock of the universe begins to slow, not because something is broken, but because there's less and less difference between one moment and the next. When every particle occupies the same position, when every vibration synchronizes, time loses its meaning. It's as if the universe is inhaling its final breath. We think of that as an end, but maybe it's more like the pause between heartbeats. Einstein once said that the distinction between past, present, and future is only a stubbornly persistent illusion. In relativity, time doesn't flow, it is. All events exist simultaneously in a vast four-dimensional landscape, what physicists call space-time. The Big Bang, the formation of Earth, the birth of stars, you're listening to this story. They all coexist in the fabric of reality, frozen in different coordinates. Our consciousness moves through it like a flashlight scanning across a painting, illuminating one frame at a time. So if the universe collapses and space-time itself curls inward, maybe what dies is not time, but our journey through it. Imagine for a moment being in that final instant, every particle you've ever known drawn toward the same singular point. Light can no longer escape, there's nowhere left to go. Temperature rises beyond comprehension, and yet motion slows. Energy folds into geometry. Space and time merge into one final state. Pure potential, infinite density, no direction, no duration. If you could somehow exist there, you wouldn't notice time ending. There would be no before, no after, no waiting. Just a constant, eternal now. Some theories suggest that in this moment, quantum fluctuations might reignite, the same kind of fluctuations that once gave birth to the cosmos. If so, then the end of time is not a full stop, but a reset, a turning of the cosmic page. From our limited human perspective, the collapse feels terminal, but to the universe, endings and beginnings are just two halves of the same rhythm. When time folds in on itself, it's like music returning to its first note, a completion so perfect that it demands to start again. There's also another, more subtle idea that time never truly ends because it never truly began. Some cosmologists propose that the Big Bang wasn't a moment of creation at all. It was simply a boundary in time. Before it, time may have flowed differently, perhaps in reverse or in some form beyond our comprehension. Likewise, the Big Crunch could be the mirror boundary at the other end. From outside, the two boundaries might be connected, like the poles of a sphere. In that picture, our universe doesn't have a beginning or an end. It just is. An eternal loop, a timeless whole. This brings us to the edge of philosophy. If time ends, what happens to meaning? So much of what we value, life, love, hope, memory, depends on moments. Without time, can those things exist, or do they transcend it, encoded forever in the unchanging structure of space-time itself? Perhaps every thought, every act of kindness, every dream ever dreamt, remains etched somewhere in that grand cosmic map, unaltered, eternal. In that sense, nothing is ever truly lost, only unreachable from where we stand. So as the last star fades and the final photon curls inward, remember this: the end of time doesn't mean the end of existence. It may simply be the universe returning to silence, a pause before the next verse of its infinite song, and maybe, somewhere in that silence, consciousness still stirs. Maybe awareness, like a spark in the dark, lingers, waiting to awaken again when a new timeline unfolds. If that thought comforted you or filled you with wonder, press like, subscribe, and stay with me here on Space for Sleep. Because in our next chapter, we'll ask an even deeper question. When time ends, what happens to memory? They say the past is gone. That time moves forward, leaving behind only echoes. But what if nothing truly disappears? What if, somewhere deep in the fabric of reality, every moment that has ever existed is still there, frozen, shimmering, waiting? Physicists call this the block universe, a model where every event, from the birth of the cosmos to this exact instant, coexists in spacetime like scenes in a film reel. We experience them one frame at a time, but all the frames already exist. In that sense, the universe doesn't have memory. It is memory. Every atom that makes up your body remembers the heat of ancient stars. Every photon of light that touches your skin carries a story billions of years old. The past isn't behind us, it's within us. At the heart of this idea lies a haunting question. When the universe collapses, do those memories survive, or are they erased forever in the compression of spacetime? Entropy, the great arrow of time, tells us that order always decays. Information spreads, scatters, becomes unreachable. But according to the laws of quantum mechanics, information itself can never be destroyed. It can change form, but it must always persist. This is known as the law of information conservation, a principle that some physicists believe is as fundamental as energy itself. When Stephen Hawking studied black holes, he faced a paradox. If matter falls into a black hole and vanishes, what happens to the information it contained? Does the universe lose those details forever? If so, it would violate quantum law. But if information somehow escapes, encoded, transformed, or imprinted on the event horizon, then even a black hole becomes a kind of cosmic memory bank. Today, most physicists believe that information isn't lost, even inside a black hole. It's scrambled, hidden, nearly impossible to decode, but not gone. Like a whisper trapped in the fabric of space. Now, imagine the Big Crunch as the ultimate black hole, the collapse of everything into one cosmic horizon. Could the information of all existence, every thought, every star, every note of music, still remain encoded there, in some incomprehensible form? If so, then the end of the universe isn't the loss of memory. It's the universe remembering itself perfectly. And that brings us to an even deeper possibility, one that reaches beyond physics and touches the soul. If information is eternal, then so is experience. The patterns that make up your thoughts, your emotions, your awareness, they are all information. When you die, that information doesn't vanish, it transforms. It disperses into the cosmic background, woven into the structure of space-time. You return to the memory of the universe. So perhaps in some unimaginable way, the universe never forgets us. It keeps everything, every laugh, every tear, every act of love written into its code. When we gaze up at the night sky, we're not just looking at stars, we're looking at time. The light we see left those suns thousands, millions, or even billions of years ago. We're literally looking into the past. That faint glow of starlight is the memory of the cosmos, streaming toward us across ages of darkness. Each photon is a messenger from a long-lost moment, proof that nothing truly fades, it only travels. So when you look at the Milky Way, stretching like a silver river above, know that you're looking at the living archive of existence. Even our planet remembers. The rocks beneath our feet hold the fingerprints of ancient oceans. The air we breathe carries atoms once inhaled by dinosaurs, poets, and kings. The universe recycles itself endlessly, reshuffling, rewriting, but never deleting. We are part of that grand continuity. Not isolated minds drifting in time, but moments in the great memory field of the cosmos. We are remembered because we are the remembering. Now imagine the final instant of the Big Crunch. Every particle collapses back into unity, every piece of information converging. No more distance, no more delay. Every thought, every event, every life, reunited in a single, timeless whole. The universe, for one brief instant, becomes perfectly aware of itself. All memories merge into one, the story of everything. Maybe that is the purpose of collapse, not destruction, but integration. The cosmos remembering everything it ever was before becoming something new. So when people ask, does the universe have consciousness? Perhaps the better question is, does the universe have memory? And maybe the two are the same. Because what is consciousness if not the awareness of past and present? What is memory if not the persistence of being? If the universe holds on to everything, every pattern, every echo, every vibration, then in a sense, it never sleeps. It only dreams. As you breathe now, think of this. You are breathing the same atoms that once drifted through stars. You are part of an ancient memory still unfolding. The universe does not forget you. You are written into its story. So close your eyes and let that thought settle like stardust in your mind. Because in the next chapter, we'll go even deeper into what might happen after the collapse, when memory becomes creation again. If you're still with me, please like this video, subscribe to Space for Sleep, and join me next time as we explore the rebirth of the cosmos. Imagine the final silence after the collapse. A silence so deep that even the idea of silence disappears. All space, all time, all energy drawn inward to a single infinite point. No stars, no galaxies, just density. Pure, luminous potential waiting for release. And then, something stirs. A ripple moves across the quantum foam. A whisper in the void. A flicker of imbalance in the perfect symmetry. It doesn't happen in time. It creates time. That ripple is the first heartbeat of a new universe. From that infinitesimal spark, expansion begins again. Not an explosion, but an unfolding, space-time stretching, cooling, blossoming like the petals of a flower too vast for imagination. In an instant smaller than an instant, energy floods outward. Temperature soars to trillions of degrees. Quarks and gluons dance in the primal storm, colliding, separating, merging again. For the first few moments, the universe is a furnace of creation, chaotic, radiant, alive, and yet within that chaos, a strange order emerges. For every particle created, an antiparticle forms beside it, mirror twins. Most annihilate each other instantly, releasing floods of light. But for reasons still mysterious, a few particles survive, a tiny imbalance that becomes everything. Those survivors, 1 in a billion, form the matter that will one day become galaxies, stars, planets, and you. The universe expands, it cools. Hydrogen and helium nuclei form. The first atoms take shape, and with them, the first light that can travel freely. The faint afterglow we now see as the cosmic microwave background. Even now, that ancient light still surrounds us, a gentle whisper from 8 billion years ago, the baby picture of everything. If the universe could remember its first dream, this would be it. A field of soft radiation, cooling and stretching with time, carrying in its pattern the code of all that will follow. As the eons unfold, gravity begins its quiet work. Matter gathers, clouds condense, stars ignite. Each star is a new experiment, a furnace, turning hydrogen into heavier elements, building the ingredients of life. When they die, they scatter those elements into space, seeding new generations of stars and worlds. The universe learns through repetition, through creation, destruction, and rebirth. Every supernova is both an ending and a beginning. Every collapse makes way for light. Even in death, the cosmos grows wiser. If we could stand outside of time and watch it all at once, the collapse of the old universe and the birth of the new, we might see that there is no gap at all. One universe ends exactly where the next begins, like waves overlapping on a boundless sea. The Big Crunch becomes the Big Bang, and the cycle continues forever, an endless heartbeat of creation and return. Some physicists call this the cyclic universe model, an eternal rhythm where each cosmos gives birth to the next. Others call it the Big Bounce. But perhaps it's something even more poetic, a breathing universe, an infinite inhale and exhale of existence itself. And where are we in this cycle? We are the awareness that arises in between breaths. The universe, in its expansion phase, becomes complex enough to dream, to form consciousness, curiosity, wonder. We are how it looks back at itself and asks, "Who am I?" That question is the bridge between collapse and creation. Maybe that's why awareness exists, to carry memory across the silence, to connect one universe to the next. When you think, when you love, when you gaze at the stars, you're participating in that eternal rebirth. You are the universe remembering how to begin again. Now, picture this. Billions of years after the new Big Bang, a planet forms around a yellow star in a quiet corner of a spiral galaxy. On that planet, life takes hold, fragile, improbable, miraculous. Atoms that once swirled in the heart of ancient stars become oceans, forests, eyes and minds. And one night, a being of that life sits quietly, listening to the story of how it all began. A story told by the universe itself, through you. You are both the storyteller and the story. Perhaps that's what rebirth really means. Not just physical renewal, but the reawakening of meaning, the rediscovery of wonder. Each time the cosmos blooms anew, it creates new eyes to see itself, new voices to sing its song, new hearts to feel its mystery. The cycle is not punishment or repetition, it is evolution. Each iteration of the universe learns something the last could not. If that thought fills you with peace, take a deep breath. You are part of a rhythm that never truly ends. When this universe collapses, another will bloom. When this breath fades, another will rise. You are not a separate observer of the cosmos. You are its continuation. So as you close your eyes tonight, imagine yourself drifting between breaths of creation. In that stillness, you are eternal. And if you've journeyed this far with me, please like, subscribe, and stay close. Because next time on Space for Sleep, we'll travel into something even stranger, a universe where physics and imagination blur, the multiverse hypothesis. What if this universe, everything we know, everything we are, is just one verse in an infinite cosmic song? We've traced the cycle of expansion and collapse, seen the universe die and be reborn. But there's another possibility, one far stranger and far more humbling. Maybe our cosmos isn't alone. Maybe reality itself is a vast ocean, and our universe, just a single, shimmering bubble floating on its surface. The idea of the multiverse isn't new. It has appeared in philosophy, myth, and now science. From ancient Indian cosmology's endless cycles of creation to modern string theory's 1, 0, 50, 0 possible dimensions, the question remains the same. If one universe can exist, why not many? After all, the laws of physics don't seem to forbid it. And if nature can create one universe, perhaps it has done so countless times, each with its own laws, constants, and possibilities. Let's start with the first version physicists call the inflationary multiverse. When our universe was born, it expanded faster than light for a fraction of a second, a process called cosmic inflation. But what if inflation didn't end everywhere at once? What if different regions of space stopped inflating at different times? Each region would then form its own bubble universe, sealed off from the rest by expanding space. Inside each bubble, physics might play by different rules, different strengths of gravity, different constants of nature, even different kinds of particles. In that scenario, there isn't just one Big Bang. There are infinite Big Bangs, popping like sparks in the dark sea of reality. Our universe is just one such spark, a single glowing bubble drifting among countless others. Then there's the quantum multiverse, born from the weirdness of quantum mechanics itself. In this interpretation, the many worlds theory, every time a quantum event can go two ways, the universe splits. One universe where the electron goes left, another where it goes right. One universe where you clicked on this video, another where you didn't. Each choice, each probability, each uncertainty creates a branching of realities, a cosmic tree whose roots reach forever backward. and whose leaves shimmer across infinity. In that view, everything that can happen does happen, not somewhere far away, but in universes stacked invisibly beside our own. Now imagine those two ideas together, an inflationary landscape filled with quantum branching. Each bubble universe splits endlessly within itself, and every split gives rise to another kind of infinity. If true, then existence is not just large, it is unbounded. Every dream, every possibility, every law of physics plays out somewhere, in some world forever. And yet, here you are, in this one. That's what makes the multiverse both fascinating and deeply human, because it raises the question, why this one? Why do we find ourselves in a universe perfectly balanced for life? If gravity were a little stronger, stars would collapse too soon. If it were weaker, galaxies would never form. The constants of nature seem exquisitely tuned, almost impossibly so. Physicists call this the fine-tuning problem, and one possible solution is simple but profound. There are countless universes, each with its own settings. We just happen to live in the one where life can exist, because only in such a universe could anyone ask the question. But there's another, quieter interpretation, not scientific but poetic. What if all those possible universes are not separate places, but different expressions of the same eternal source? Different ways the cosmos dreams of itself. Different verses in the infinite poem of being. In that sense, our universe isn't isolated. It's harmonious. Every law, every constant, every particle is part of a greater composition, a symphony of realities that together form the totality of existence. You are listening to one note in that song right now, and though you can't hear the others, they're still resonating, softly, beautifully, beyond the edge of comprehension. If the multiverse exists, then perhaps the collapse of one universe isn't an end at all. It's simply a return to that wider sea. When the big crunch comes, our cosmos might dissolve back into the field that birthed it, its information merging with infinite others. The memory of our universe, its history, its light, its minds, might ripple across the multiverse forever. And somewhere, in another bubble, a new universe might be born carrying a faint echo of us. A vibration, a pattern, a whisper in its physical laws that remembers where it came from. Perhaps that is what rebirth truly means. As you breathe now, think about this. For all the vastness, for all the infinite variations, you are here, now, in this particular universe, on this particular world, made of these particular atoms. The odds are unimaginable, and yet you exist. You are not a random accident. You are the multiverse, focusing itself into a single moment of awareness. So if you've made it this far, take a slow, deep breath. You are the observer and the observed, the question and the answer, the verse and the song. And if that idea made you feel a little smaller, or a little more infinite, press like, subscribe, and let your consciousness drift through the cosmos with me. Because next time, we'll venture into one of the most haunting ideas in physics. If there are infinite universes, could they ever meet? Could they ever collide? Imagine an endless ocean of universes, bubbles of space-time expanding, drifting, each born from its own Big Bang, each carrying its own laws of physics like a genetic code. Now imagine two of those cosmic bubbles slowly growing, pushing outward through the vacuum of a higher dimensional space, and then one day their edges touch. What happens when universes collide? The idea sounds like science fiction, but in modern cosmology, it's a very real question. Some physicists believe that our own universe may actually bear the scars of such a collision, written faintly in the cosmic microwave background, the afterglow of the Big Bang. To understand this, we have to step into the mind of the early universe, into the chaotic fraction of a second after time began. Space itself was expanding faster than light, a storm of inflation driven by quantum fields. If those fields hiccuped, if inflation ended unevenly, then bubbles of new universes could have formed side by side, each expanding, each isolated, until expansion brought them close enough to meet. Picture it. Two cosmic spheres of space-time racing toward each other at unimaginable speeds. They don't collide like billiard balls or galaxies. They merge like overlapping realities. The fabric of one universe presses against the other, causing a shockwave of energy, a distortion that ripples through both. In the aftermath, the border between them could glow with unimaginable heat. That energy might seed new matter, perhaps even spawn yet another universe, a child of two cosmic parents. Some cosmologists, like those exploring brain theory and string physics, suggest that our own Big Bang might have been caused by such an event. In that framework, our universe exists as a three-dimensional membrane, a brain, floating in a higher dimensional space called the bulk. When another brain collided with ours, the impact released a burst of energy so immense that it created all the matter and radiation we now see. In other words, our universe could be the aftermath of two higher dimensional worlds brushing together for a moment in eternity. If that's true, then cosmic collisions aren't rare accidents. They're the heartbeat of creation. Each collision births a new universe, each impact lighting a new spark in the infinite dark. But what would it look like if it happened again? If another universe's edge brushed ours, what signs would we see? Some theorists think it might leave circular imprints in the cosmic microwave background, faint rings of temperature variations like ripples spreading across a frozen pond. Others suggest gravitational waves, faint tremors in space-time that would echo across billions of light years. We've looked for those signs. We've searched the CMB, scanned the sky with the precision of satellites like WMAP and Planck, and while some patterns hint at anomalies, nothing yet confirms a collision for sure, but the possibility remains, a mystery still whispering through the static of the universe's first light. Now, think about what a cosmic collision means on a deeper level. If universes can touch, can merge, can give birth to new ones, then maybe existence isn't a hierarchy of beginnings and ends, but a vast ecology of creation. Each universe lives, grows, and dies, feeding the next in an infinite cycle of renewal. A cosmic ecosystem of birth, collapse, and rebirth, stretching across dimensions beyond imagination. And within that cosmic ecosystem, our little world drifts like a cell in a boundless organism, alive, conscious, aware. But there's something else to consider. If two universes can collide, could consciousness itself, your awareness, my voice, the act of thinking, be a kind of collision too? When you perceive reality, you're bringing two worlds together, the inner universe of your mind and the outer universe of matter. Each thought, each moment of awareness is a gentle merging of those realities, a small echo of that grand cosmic event. You are, in a sense, a microcosmic universe collision, a meeting point between the infinite and the intimate. And if we return to the multiverse, the infinite foam of universes bubbling across dimensions, perhaps consciousness itself is how the cosmos connects them. Each conscious being a tiny bridge, a node of awareness linking countless possible worlds. So when you look up at the night sky, you're not just seeing distant galaxies. You're feeling the edges of other universes brushing against your imagination. When you close your eyes tonight, try to picture that slow, silent collision. Two glowing spheres of reality drifting through the void, touching for the briefest instant, and from that touch, a whole new universe is born. Maybe that's how it all began. Maybe that's how it will begin again. And maybe, right now, as you listen to these words, the ripples of one universe are quietly reaching into another, through sound, through thought, through you. If that thought moved you, if you can feel that strange connection between everything, please like this video, subscribe to Space for Sleep, and stay with me. Because next time, we'll explore something even deeper. What if consciousness itself is the key to holding the universe together? Next episode, the quantum mind. Close your eyes for a moment, listen to the sound of your own breathing, feel your heartbeat, steady, rhythmic, soft. Now ask yourself a question so simple, it's almost invisible. who is the one listening? Who is the one aware of the breath, the heartbeat, the silence between them? That question, who am I, might be the most profound quantum experiment of all. We've traveled across collapsing universes, through infinite multiverses and cosmic collisions. But now, we turn inward, into the smallest, most elusive frontier in existence, consciousness. Because for all our equations, telescopes, and theories, the greatest mystery isn't out there among the stars. It's the fact that you can look at them and wonder, how does awareness arise from matter? How does the electrical hum of neurons become thoughts, emotions, dreams? And could the secret lie not in biology, but in the strange, uncertain world of quantum mechanics itself? This idea, the quantum mind hypothesis, suggests that consciousness might not just emerge from the brain, but from the very fabric of reality. That perhaps the mind doesn't merely observe the quantum world, it participates in it. After all, at the subatomic level, observation changes everything. In the famous double-slit experiment, particles act like waves, spreading out in possibility until someone observes them. Then the wave collapses and the particle chooses a single path. The act of observation itself alters the outcome. So what is doing the observing? Is it the brain or something deeper, awareness itself? Some physicists and philosophers have wondered if consciousness is woven into the universe at its deepest level, as fundamental as space, time, or energy. That idea is called panpsychism, the notion that every particle, every atom, every photon carries a tiny glimmer of awareness. If true, then the universe isn't made of dead matter. It's made of experience. And you, your mind, your thoughts, your dreams, are the universe recognizing itself. One of the most intriguing models of this idea comes from theoretical physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. They proposed that consciousness arises from quantum processes inside tiny structures within neurons called microtubules. According to their theory, orchestrated objective reduction, or ORCH, these quantum states collapse in a way that gives rise to conscious moments. In essence, your awareness may be the universe's quantum computations happening within the living architecture of your brain. It's controversial, it's debated, but it's undeniably poetic. The idea that every thought you have is a quantum event rippling through space-time. If consciousness truly connects to the quantum world, then maybe awareness doesn't end with the body. Maybe it's part of the same field that weaves reality together. When the universe collapses, when matter dissolves, the information, the pattern of awareness, may not vanish. It might rejoin the quantum field, waiting to awaken again in another form, another world, another breath. You could say consciousness is how the universe keeps dreaming, even as stars are born and die, an unbroken thread running through all of time. Think of your mind as a kind of quantum antenna. Every thought is a resonance, a vibration, tuned to the frequencies of the cosmos. Sometimes, when you feel awe, love, or deep peace, it's as though you realigning perfectly with the harmonic heartbeat of existence itself. That's why looking at the night sky can make you feel both tiny and infinite. You're not just seeing stars, you're remembering them, because somewhere deep within you, the same quantum patterns that shape galaxies also shape thought. You are the echo of the cosmos thinking about itself. And maybe, just maybe, consciousness is the bridge that allows universes to communicate. When two realities touch, they don't need words or equations. They need awareness, a shared vibration of understanding. If consciousness is fundamental, then every moment of realization, every spark of compassion is a tiny act of cosmic unity, a collision not of matter, but of meaning. So, when you sit in stillness, when your thoughts quiet and your awareness expands, you're not escaping the universe, you're joining it. You're aligning with the quantum hum that connects all things. And in that silence, if you listen closely enough, you might even hear it. the faint whisper of existence itself, the universe breathing through you. If this journey through the quantum mind stirred something in you, remember, you are not separate from the cosmos. You are its awareness made flesh. You are the observer and the observed, the dreamer and the dream. So before you drift to sleep tonight, whisper a thank you to the atoms, to the stars, to the infinite awareness that became you. And if that idea filled you with wonder, please like this video, subscribe to Space for Sleep, and stay tuned, because next time we're going to explore what happens when awareness itself becomes the architect of reality. Let's begin with a simple, haunting question. Does reality exist before we look at it? It sounds absurd. Of course it does. The moon is still there when no one's watching. The stars burn whether or not we see them. And yet, in the strange subatomic world, reality doesn't seem to behave that way. At the quantum level, the act of observation appears to create what we see. This is the observer effect, one of the most profound and unsettling discoveries in all of science. In the double-slit experiment, a single photon, a particle of light, is fired toward a barrier with two slits. If no one measures which slit it goes through, the photon behaves like a wave, passing through both slits at once and creating an interference pattern on the screen beyond. But if we place a detector to observe its path, the interference vanishes. The photon acts like a particle, choosing one slit or the other. The only thing that changes is observation. Just the act of watching turns possibilities into a single outcome. It's as if the universe doesn't decide what's real until consciousness looks at it. What does that mean? Is the observer creating reality? Or is observation simply the moment when potential becomes actual? Some physicists, like John Wheeler, suggested that the universe is participatory, that reality requires observers to bring it into being. He called it the participatory anthropic principle. In a way, the cosmos creates observers so that it can exist through their awareness. In other words, without consciousness, there might be no definite reality at all, just a shimmering ocean of probabilities. Think about that for a moment. Every time you perceive something, a sound, a color, a memory, you're collapsing an infinite wave of possibilities into one unique moment of existence. You're turning potential into experience. You, the observer, are participating in the ongoing act of creation. This doesn't mean you can wish objects into existence. Quantum mechanics doesn't bend to human desire. But it does mean that the line between observer and universe is far thinner than we once imagined. You are not standing outside the cosmos looking in. You are inside it, part of the process through which reality becomes real. Now imagine scaling that idea upward, from single particles to stars, galaxies, and consciousness itself. Could the universe require observers on a cosmic level? Could awareness be the mechanism by which the universe knows it exists? It's a chillingly elegant thought. The universe has been waiting billions of years to look back at itself through your eyes. In a very real way, each of us is an instrument of measurement, a living detector through which the universe gathers information about itself. When you look up at the Milky Way, you're not just seeing light that has traveled for thousands of years. You're finalizing that light's journey. You're giving it meaning by perceiving it. Without observation, that starlight would remain suspended in probability, a whisper waiting to be heard. And maybe that's what consciousness is, the universe's way of listening to its own song. Some physicists even wonder whether the universe as a whole behaves like a quantum system. If so, the act of observation might not just define small-scale events. It could influence the very structure of space-time itself. Imagine every conscious mind as a tiny quantum observer, each collapsing waves of probability into patterns of matter, energy, and experience. Collectively, all consciousness together might form a vast distributed field of observation, the cosmic mind. If that's true, then reality isn't static. It's alive, responsive, evolving with every moment of awareness. But let's go deeper. If the universe depends on observation to become real, then who observed the first moments of the Big Bang? Before stars, before life, before eyes to see? Who or what was watching? Wheeler suggested something radical, that observation doesn't just happen forward in time, it can reach backward too. In his delayed choice experiments, the act of observing a particle now can influence how it behaved in the past. In other words, our present observation can help determine the history of the universe. If that's true, then consciousness doesn't just participate in reality, it weaves it across time. Every act of perception helps shape the past as well as the present. We're not passengers in a pre-written universe, we are co-authors of its story. So when you look at the stars tonight, remember, you are completing a sentence the universe began billions of years ago. The light from those stars has been traveling since before Earth existed, but it didn't truly arrive until it entered your eyes. Until awareness met the photon, that journey was still unfinished. In that instant of seeing, the universe completes itself through you. You are the final moment of creation, and if that realization makes your heart slow, if it fills you with quiet awe, let it. You are not small, you are not separate, you are part of the very act of being. You are the observer, and through you, reality becomes real. If this resonated with you, please like this video, subscribe to Space for Sleep, and join me next time as we explore what might lie beyond the limits of observation, a realm where even time and reality themselves begin to blur. Close your eyes. Take a deep breath. Feel the passing of this moment, the soft rhythm of now. Now ask yourself, what is a moment? Where does it begin? Where does it go when it ends? We live our lives inside time, a constant flow that carries us from past to future, one heartbeat, one thought, one memory at a time. But physics tells us something strange. Time may not be what it seems. To us, time feels like a river, flowing steadily forward, unstoppable. The past fixed behind us, the future waiting ahead. But in the world of quantum mechanics and relativity, that flow starts to blur. Einstein once said, "People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion." What if he was right? What if all of time, every second of history, every heartbeat of the future, already exists simultaneously, like frames of an infinite film reel? Physicists call this the block universe theory. In it, time doesn't flow. Instead, every moment, from the birth of stars to your next breath, already exists within the structure of space-time. Imagine a loaf of bread, each slice representing a moment in time. We, as conscious beings, only ever perceive one slice at a time, the now. But the loaf, the entire structure of reality, exists all at once. We just move through it, one thin layer at a time, like a flashlight scanning across a frozen landscape. In that view, the future isn't something that will happen. It's something that already is. We simply haven't reached the slice where we experience it yet. But if time is an illusion, if all moments exist together, then what does change even mean? What is motion or growth or life itself? Perhaps time isn't flowing at all. Perhaps consciousness is moving through time, like a traveler wandering through a vast cosmic museum, stopping to gaze at each exhibit of existence before stepping silently to the next. You don't have time. You are time, a point of awareness sliding along the dimension of your own becoming. Quantum physics takes this even further. In the subatomic world, cause and effect aren't so clear. Events don't always happen in order. Sometimes the outcome of an experiment can seem to decide its own past. In quantum entanglement, particles separated by light years can instantaneously affect each other, as if distance and time simply don't exist. This isn't just theory, it's been observed, tested, proven. Reality itself refuses to obey our human sense of before and after. It behaves as though all time is now. And if all of time is now, if every moment exists at once, then perhaps your birth, your future, and your final breath are all happening simultaneously, woven together in the eternal present. In that sense, death isn't an ending. It's simply a shift of awareness, a movement from one slice of space-time to another. The universe doesn't destroy information, it only rearranges it. so the moments of your life never truly vanish. They remain, echoes suspended forever in the fabric of reality. Maybe memory itself is how consciousness reaches backward through time, touching what still exists, like fingertips tracing old constellations in the dark. So, if time is an illusion, what does that make you? You are the observer who turns that illusion into experience. Your perception gives time its meaning. Without awareness, there is no past, no future, only the eternal now. Everything you've ever loved, every dream, every fear, exists here, in this timeless field of being. And maybe that's what enlightenment really is. Not an escape from time, but an awakening within it, a realization that every moment is forever. Now, take another slow breath. The air enters your lungs, molecules older than the earth itself. Each atom inside you has lived through countless ages, born in stars, carried through oceans, woven into life again and again. They've never been gone, only transformed, just like you. In the deep structure of the cosmos, nothing truly passes away. Moments, like matter, are never lost, only hidden from view. You're not drifting through time, you're dancing with it. You are the movement, you are the moment. So tonight, as you listen to this, let go of the fear of running out of time. You're not in a race against the clock. You are the clock, the heartbeat of the universe counting itself into being. And somewhere beyond your next breath, beyond the illusion of seconds and centuries, there's a stillness that never changes, the eternal present, the place where everything that ever was and ever will be exists together, right now. If that thought brought you peace, please like this video, subscribe to Space for Sleep, and stay close, because in the next section, we're going to step beyond the illusion of time and look at something even deeper. What if reality itself is a simulation? Take a moment. Look around you. The light, the air, the sound of your own breath. Everything seems real. But what if all of it isn't? What if the stars above, the ground beneath your feet, even the thoughts inside your head are part of something greater, something built, something coded? Tonight, we step into one of the most unsettling and fascinating questions science and philosophy have ever asked. What if the universe itself is a simulation? This isn't science fiction anymore. It's a theory that serious physicists, cosmologists, and computer scientists now openly discuss. The idea goes something like this. If civilizations can one day simulate entire worlds, complete with conscious beings who think, feel, and dream, then who's to say we're not already inside one of those simulations? Maybe the universe you know, the galaxies, atoms, even quantum particles, are part of a massive computational structure running somewhere beyond the boundaries of our reality. Let's break that down. In a video game, everything you see, mountains, oceans, cities, isn't real in the physical sense. It's data, information. It exists only when rendered, when the system needs it to. Now imagine a civilization far more advanced than ours, capable of building simulations not just of landscapes, but of entire universes. They wouldn't need to program every molecule in existence, only the parts that are being observed. Sound familiar? It's eerily close to what quantum mechanics tells us, that particles don't have definite properties until they're measured or observed. It's as if the universe is rendering itself in response to consciousness, just like a simulation rendering pixels when a player turns their head. That's one of the strangest connections between physics and the simulation idea, quantum observation. In the famous double-slit experiment, light behaves like a wave until it's observed. Then it collapses into particles. The act of watching changes the outcome. If our reality is being generated, it would make perfect sense for the universe to save processing power by only creating detail where attention is focused. The rest could remain a fuzzy probability cloud until observed. It sounds absurd, and yet that's exactly how the quantum world behaves. Nick Bostrom, a philosopher at Oxford, made the idea famous in his 2003 paper. Are you living in a computer simulation? He proposed three possibilities. 1. no civilization will ever reach the technological level to create simulated worlds. 2. Civilizations that do reach that level will choose not to run simulations. 3. We're almost certainly living in one already. If the first two are false, if technology can and will reach that stage, then statistically the third option becomes almost impossible to avoid. Because if even one advanced civilization runs millions of simulations, the number of simulated realities will vastly outnumber the base reality. That would mean the odds of us being in the original universe are almost zero. Let's push this thought experiment further. If the universe is a simulation, then everything, from galaxies to gravity, is code, and physics is simply the programming language of reality. Equations aren't just descriptions of how the universe behaves, they're the syntax that defines it. Energy, matter, motion, all emergent behaviors from underlying computational rules. Even the famous Planck scale, the smallest possible unit of measurement, could represent the pixels of the cosmos, the minimum resolution of the simulation. Beneath that, nothing exists. No space, no time, just raw data. It's a breathtaking and terrifying thought. If reality is simulated, then somewhere, beyond the veil, there are creators, programmers, beings who made all this. Maybe they built it for research, maybe for art, maybe just for curiosity, to see what consciousness would do when given stars and atoms and love. Or maybe we are the latest in a long chain of simulations, each creating the next, universes inside universes, nested like digital Russian dolls, stretching into infinity. And if that's true, then what happens when our simulation ends? Would we know? Would there be signs, glitches, moments when the code reveals itself? Some physicists think so. They've searched for pixelation in cosmic rays, looking for evidence of limits in energy that might indicate a computational grid underlying reality. Others look at quantum randomness and wonder if it's truly random or simply the output of an algorithm we can't yet decipher. Even the laws of physics, constant and universal, might be part of a cosmic operating system. Change a single constant and the universe crashes, like a program error in existence itself. But let's pause for a moment. Even if this were true, even if the universe is simulated, does it change how you live your life? If you laugh, love, dream and feel, aren't those experiences still real to you? If the stars you see are code, does it make their beauty any less profound? Maybe not. Maybe what matters isn't whether the universe is real, but whether it's meaningful. And meaning comes from consciousness, from the observer, not the program. Perhaps the simulation itself is alive, self-aware through us, the universe experiencing itself through every conscious being inside it. So, tonight, as you lie beneath this coded sky, ask yourself, if reality is a simulation, who or what is watching from the outside? And if everything you do is being rendered in real time, then the act of watching, wondering, questioning the code might just be the simulation's purpose. Maybe we are the experiment. Maybe curiosity's the program. So keep asking, keep observing, keep dreaming, because in a universe that might be simulated, your awareness is the only thing that feels truly real. If that thought expanded your mind, please like this video and subscribe to Space for Sleep for more quiet journeys through the mysteries of existence. And in the next section, we're going even deeper, beyond simulations, beyond time, to the question at the center of everything. Why does anything exist at all? Close your eyes, feel the stillness, the air around you, the soft hum of being. Before time, before space, before the first particle of matter, there was nothing, no stars, no laws, no mind to notice, and yet, here we are. Everything you've ever known, every sound, color, heartbeat, galaxy, somehow exists, and that, more than anything else, is the greatest mystery of all. Why does anything exist instead of nothing at all? Physicists can describe how the universe began. They can tell us about the Big Bang, quantum fluctuations, inflation, the birth of particles. But the deeper question, the why, remains untouched. Why did the universe come into being? Why are there laws of physics at all? Why not just emptiness? It's the oldest question in philosophy, and it haunts both mystics and scientists alike. Some say the universe needed no reason, that existence is simply what reality does, that nothingness is unstable and eventually it had to become something. Others say there was never nothing to begin with, only potential, a kind of eternal possibility waiting to realize itself through consciousness. Imagine nothing, not darkness, because darkness is still something, not space, because space has dimension. Imagine the absence of everything, even the concept of absence itself. Can you? Of course not, because the moment you try, you've already created a thought, a flicker of something within the void. Maybe that's what happened at the beginning. Maybe the first something was awareness itself, the spark that could notice the nothing. And from that noticing, existence unfolded, a cosmic self-realization. Quantum physics tells us that the vacuum, what we call empty space, isn't really empty at all. It teems with energy, with particles flickering in and out of existence every instant. Even the void cannot stay still. Perhaps that's the universe's secret, that pure nothingness is impossible, because the potential for something is itself something. Maybe existence isn't the opposite of nothing. Maybe it's what nothing inevitably becomes when it tries to be perfect silence. And if that's true, then everything, stars, planets, people, are the natural language of existence speaking itself aloud. You are not separate from the universe. You are a sentence in its story, a thought the cosmos is thinking. Just as waves belong to the ocean, you belong to being itself. There is no border between you and the infinite. You are the infinite temporarily taking form. Philosophers like Spinoza, Schopenhauer, and Alan Watts have all suggested that existence might be the universe becoming aware of itself. That consciousness is not a product of matter, but rather matter is a way for consciousness to experience itself. If that's true, then everything that exists exists because it must, because awareness demands an object to be aware of. Without the universe, consciousness has nothing to perceive. Without consciousness, the universe has no one to perceive it. Each gives the other meaning. They are two sides of the same cosmic mirror. Think about your own existence for a moment. You didn't ask to be born. You simply appeared. A brief flicker of awareness inside the vastness of being. And yet, from your perspective, everything exists only because you can see it. If you weren't conscious, would the stars still shine? Would beauty still mean anything? You carry the whole universe inside your awareness. Every sight, sound, and memory is painted on the canvas of your mind. Maybe that's what existence is, the universe dreaming through every observer, endlessly experiencing itself from countless points of view. Now, here's a thought that bends the mind even more. What if existence didn't begin? What if it always was, eternal, uncaused, without a starting point? We tend to think everything must have a cause. Every effect must come from something. But what if being itself needs no cause? What if existence is the one thing that can't not be? Just as one can't imagine a square circle, maybe it's impossible to imagine true non-existence. Perhaps the universe doesn't happen. It is. And maybe, when you stare into the night sky, you're not looking outward, but inward, into the deepest layer of yourself. Every photon that hits your eye has traveled billions of years, only to end its journey in your mind, where it becomes awareness. The universe perceives itself through your gaze, and that might be the reason it exists at all, to know itself, to witness its own beauty, to be seen. If there's one lesson in all this, it's that existence, this miracle of being, doesn't need justification. It's already complete, already sacred. The fact that you can hear my voice, that stars burn above you, that thoughts and dreams exist is enough. You are existence, and existence is you. So tonight, as you drift to sleep beneath the quiet hum of reality, let this thought cradle you. You are part of the greatest mystery there is. The fact that you exist means that the universe has already chosen you to be its witness, its voice, its heartbeat. Like the cosmos itself, you are both question and answer, both silence and song, both nothing and everything. If that brought you peace, please like this video, subscribe to Space for Sleep, and let your curiosity keep glowing, because in our final section, we'll bring everything together: the quantum world, time, consciousness, and the collapse of reality, to ask one last breathtaking question: what happens after the end of the universe? So here we are, at the edge of everything. The universe has lived its long, glittering life, billions of years of stars and stories, of light crossing the dark ocean of space. And now, in this quiet moment at the end of time, we ask one final question: what happens after the universe ends? Scientists call it the heat death of the universe. A future where all stars have burned out, where matter has decayed, and only darkness remains, cold, silent, eternal. No galaxies, no light, just a vast, expanding emptiness, slowly stretching thinner and thinner until there is no difference between here and anywhere. Entropy will have won. Every structure, every atom, every memory dissolved into equilibrium. No energy left to flow, no time left to measure. The cosmos will exhale its final breath. But even that may not be the end, because in quantum mechanics, even the void is alive with possibility. Fluctuations in the vacuum could give birth to new universes, tiny sparks of reality blossoming into new cosmic inflations. The death of one universe might be the heartbeat of another. Perhaps creation and collapse are not beginnings or endings, but pulses in an infinite rhythm. Just as your breath rises and falls, the multiverse may breathe in and out, forever birthing, forever dissolving, forever dreaming itself anew. And if that's true, then maybe nothing ever truly ends. Not stars, not consciousness, not even time itself. Maybe the end of our universe is simply the transition, the moment before the next awakening, like a wave that falls only to rise again from the sea. But even if this is the final moment, the true irreversible end, there is something more enduring than matter or light: information, the patterns of existence, the stories written into the structure of being. Every atom that ever existed, every life, every memory, every thought, encoded somewhere in the deep mathematics of reality. And information, according to physics, can never be destroyed, only transformed. So even when all else fades, the pattern of the universe, its meaning, remains. Like a ghost in the dark, singing silently through the fabric of what once was. Now, imagine for a moment that consciousness, too, is one of those indestructible patterns. Maybe awareness is not a byproduct of matter, but a fundamental property of existence itself. If that's true, then perhaps awareness continues even when the universe does not. Not as memory, not as personality, but as pure, formless presence. The raw I am that exists without time or space. The same awareness that looked out from your eyes when you were a child, the same awareness that looks now, is the same awareness that watched as the first stars ignited. It has no beginning and no end. So beyond the end of the universe, what remains is being itself: stillness, silence, infinite potential, the same mystery that existed before the Big Bang, waiting patiently to dream again. Perhaps, in that infinite stillness, a spark will flicker once more, a new quantum fluctuation, a new breath of creation, and the universe will begin again, different, yet somehow the same. A new dance of matter and meaning, a new story of consciousness exploring itself. Another you, somewhere, looking up at another sky, asking the same timeless question: how did it all begin? And maybe that's the secret. There is no true end, only transformation. The universe is an eternal act of becoming, a poem without a final line. The stars burn, fade, and rise again. Galaxies swirl, collapse, and are reborn. Even in the smallest particle there is motion, a whisper of infinity. And you, You are part of that same endless motion. You are the universe, folded into human form, wondering about itself. So as we reach the final words of this journey, let this thought rest in your mind. The end is not darkness. The end is simply another kind of light, one that shines from within, the same light that burned in the first moment of creation, that flickers in every thought, that glows in every act of love. You are that light. You always have been. You always will be. And somewhere, beyond time, beyond endings, that light will rise again, to dream another universe into being. Thank you for being here, for wondering, for listening, for dreaming with me. If this journey through the cosmos touched your mind or your heart, please like this video, subscribe to Space for Sleep, and let's keep exploring together. Because as long as there are stars, questions, and consciousness itself, there will always be more to discover. Good night, traveler. Until the next universe.